This is a proof by induction divisibility question. So we're asked to prove this expression here is divisible by 7 for integers n greater or equal to 1. First thing to do is check n equals 1 then, the smallest value. And we're going to get 2 squared, because 1 plus 1 is 2, plus 5 times just 9 to the 1. That's going to equal 4 plus 45, which is 49, which is 7 times 7. And I think that's enough. Just put a little tick to show that we've done it. Okay, second step. Assume the statement is true for n equals k, some k. Maybe you could say some k greater or equal to 1 as well. Some integer, but I think that's enough. Then 2 to the k plus 1 plus 5 times 9 to the k will be divisible by 7, and we could write it as, say, 7m or 7p or whatever you want, really. There's 7 times something. M is an integer. I'm going to say that here. Right, now we want to show, I think it's always good to say this a little bit, want to show true for n equals k plus 1, i.e. 2 to the k plus 2, because I've just replaced k by k plus 1, plus 5 times 9 to the k plus 1 equals 7p. P is some other integer. Okay, now the point is, well, the method is that we're going to start with this 2 to the k plus 2. We're going to somehow use this piece of information. This is crucial to show that it's a multiple, that the purple statement's a multiple of 7. Okay, the first thing to do then is try to get it in this kind of form. What I can do actually is I can write this as 2 times 2 to the k plus 1. I've basically brought the indices down, because when you this is 2 to the 1, so if you multiply them together you add the indices. I've just done the opposite and separated it. And then I'm going to do the same over here. It's going to be 5 times 9 times 9 to the k, because I'm kind of see I've got my 5 and my 9 to the k, I've got my 2 to the k plus 1, I've just got this extra stuff. Well, what I can do now, it might be best to, no, what I'm going to do, yeah, I'm just going to put one extra line in. 2 times 2 to the k plus 1, it's going to swap those around. 9 times 5 times 9 to the k. Okay, so I've got this bit and I've got this bit. Well, to be able to use this, I need sort of as much of it together as I can. So actually, I've got 2 lots of this, and I can combine it with 2 lots of this, in fact. So I can write it as 2 times 2 to the k plus 1 plus 2 times 5 times 9 to the k, and then the remaining 7 times 5 times 9 to the k. Now I can factorize that 2 out. I've got 2 here and 2 here, so it's actually 2 lots of 2 to the k plus 1 plus 5 times 9 to the k. Now I could have actually gone straight from here. I was just trying to make it clear what I was doing. I'm combining the 2 lots of of these, and I'm just then left with the 7 lots. Okay, but the thing is, I've assumed that it's true for n equals k, and so this bit here, which is the same as this bit here, is simply 7m. So it's going to become 2 lots of 7m plus my 7 lots of 5 times 9 to the k. And this is great because I have a factor of 7 in both. I can factorize that out. It's going to be 7 lots of 2m plus 5 times 9 to the k. I'm just going to pause here and try and explain again what I've done. So yeah, we've checked if n equals 1. We've assumed it's true for n equals k. We want to show that this is true. This is kind of in the back of our minds. We start with that statement for k plus 1. Just need to manipulate it, bring the powers down appropriately. So we've got something that looks a bit like the n equals k version. And then here's the crucial bit, bringing together as much as we can together. So now I can replace that 2 to the k plus 1 plus 5 times 9 to the k by this 7m, because I've assumed that it's divisible by 7. And then what I'm left over with, brilliantly, is something that is also a multiple of 7. So I've brought it in together, and now I can simply say which is divisible by 7. Yeah, because I've taken out a factor of 7. And the thing I had before is p. Well, that is p. Okay, I could say that if I want to, but I don't think I need to. So I've done it basically. I just need to now write a conclusion. Therefore, sometimes this is actually the trickiest bit because you've got to get the wording right. Therefore, n equals k implies n equals k plus 1. Maybe I should just write that it's true. N equals k true implies n equals k plus 1 true. Since true, I'm talking about the statement being true. Since true for n equals 1, it follows by induction that the statement is true, sorry, that's right, false then, is true for n greater or equal to 1. There we go.